All right, our second and final part of statistics for Math 3 Honors is called margin of error. So we're going to go ahead and define that and then do a little math around the margin of error. So margin of error, and the shorthand for that is MOE, so you don't have to write margin of error every time, is a typically small percentage amount that is allowed for possible miscalculations or a change of circumstance. So the smaller the margin of error, the larger the number of people in the sample, the number of people in the population. So a couple things to note here. N references the sample size, how many people were sampled. The formula for margin of error is equal to 1 divided by the square root of that sample size. If I'm trying to find the sample size, I'm going to take 1 divided by the margin of error, and I'm going to square that. And I would definitely use alpha y equals there and square it. So a sample mean is the average of the sample. When we find the average of something, we add them up and divide by the number of numbers. And then we have something called the true population interval. And that's an interval, and an interval is a range of percents where we take the sample mean, the average of the means, and we add or subtract that margin of error to kind of see, how far off could we be? What's the range of miscalculation? So first thing we're going to do is just start off by finding the margin of error, and hopefully you'll be able to see a pattern of how when our sample size gets bigger, our margin of error gets smaller. We're going to round these to the nearest hundredth. So we're starting out with a sample size of 350. We're going to use that formula, margin of error equals 1 divided by the square root of our sample size. In this case, our sample size is is the square root of 350. I put that in my calculator, and I ended up getting a decimal of 0.0535. That decimal doesn't do us a lot of good. Margin of error is a percentage. So we're going to want to convert that to percentage, and we're going to say plus or minus 5.35%. That means whatever we're looking at in terms of the population interval, that we could go plus 5.35% or minus 5.35%. There's a range in terms of the margin of error, depending on the sample size. So let's say I'm sampling 35,000 people. Let's calculate the margin of error. So the margin of error is equal to 1 divided by the square root of 3,500. So we got a lot bigger, which means our margin of error should go down. So that calculated out to 0.0169, and I would encourage you to put that into Desmos and kind of see how make sure that you're getting the same thing that I am. And that's going to calculate out to plus or minus 1.69%. That's our margin of error. It could be plus, depending on what the results of our survey is. If we said 50% of the people said this, our margin of error would be 50% plus 1.69% and 50% minus 1.69%. There is a bit of an error there that we have to allow for. go ahead and look at 21,000 as our sample size. So sample size just got way bigger. So our margin of error equals 1 divided by the square root of 21,000. When I put that in my calculator, I get a very tiny decimal, 0.0069, which calculates out to plus or minus 0.69%. So your margin of error dropped significantly as your sample size grew. And then let's look at a really big sample size. Our margin of error is equal to 1 divided by the square root of 102,755. So that's going to calculate to 0.0031, which is a margin of error of plus or minus 0.31%. So a much smaller number. For the next thing we're going to do, we're going to look at the sample size required to have these margin of errors below. We're going to round our answers to the nearest whole number. So in order to do that, we're going to use that other formula. We want to find the sample size based on the margin of error. So the first thing we need to do is go ahead and change that margin of error to a decimal. So 3.5% is 0.035. Next thing we're going to do is we're going to substitute that in to our formula. N equals 1 divided by 0.035 squared. When I put that in my calculator, I'm going to round it to the nearest whole number. That means my sample size is 816. As my margin of error gets smaller, my population size should get bigger. So 1.2% is 0.012 as a decimal. I'm going to substitute that in as n equals 1 divided by 0.012 squared. I put that in my calculator and it tells me my sample size is 6,944. Now that might be people, it might be organisms, it could be a lot of different things. Looking at plus or minus 0.5%, we're going to use that as a decimal, 0.0005, little teeny tiny number. So our sample size is equal to 1 divided by 0.0005. I'm going to take that number and I'm going to square it, put it in my calculator, and I get a sample size of 4 million. A really big number. So as the margin of error gets smaller, the sample size gets bigger. So our sample size just got smaller again. So we're going to go 0.00007. 4 zeros and then the 7. So my margin of error, my sample size is equal to 1 divided by 0.00007. We're going to take that number and we're going to square it. And we end up with sample size in the millions again. But this is 204,081,633. Huge. And do practice putting that in your calculator to make sure that you get the right answers. All right, let's look at a little bit more. In a survey of 4,000 participants, so that 4,000 participants, that's my sample size. 57% said that they preferred streaming movies at home as opposed to watching a movie in a theater. We want to find the margin of error and the true population interval. So the margin of error, I can use that formula. Margin of error equals 1 divided by the square root of our 4,000 participants. So put that in my calculator, 0.0158, which becomes plus or minus 1.58%. So our margin of error is a plus 1.58% and a minus 1.58%. So now I'm going to look at what my survey said. It said 57% of the people said that this is what they prefer, but we have a margin of error. We have some wiggle room with that. So in order to find the true population interval, which is defined as an interval or a range, where the sample mean is plus or minus this margin of error. So this is my sample mean. So I'm going to take 57% and I'm going to subtract 1.58%. And that gives me 55.42%. So my margin of error can go down as low as 55.42% from that 57%. I can also say that my margin of error is 57 plus 1.58%. Sorry, these are all percentages. So that means I also have a margin of error that goes all the way up to 58.58%. So instead of having a margin of error of instead of having a result of 58%, we have this range. And that range is called your true population interval. And what that means is, because of things out of our control, maybe how the questions were asked, maybe just bad questions, we're going to have a true population interval that goes from 55.42% to 58.58% of that population actually said that they preferred streaming over the movies at home. Movies in the theater. So it's not just 57%, it's this range. All right, a survey showed that between 35% and 43% of customers like to be greeted as they enter a store. First thing we've got to do is find the sample mean of the survey, and then we have to figure out what the margin of error might have been. So for our sample mean, a mean means an average, and we're between 35% and 43%, so we're going to find the average of those two numbers, or the middle. So 35 plus 43 divided by 2 equals 39%. So right in between here is 39%. That is my sample mean. So we'll label that as our sample mean. So we've answered the first question. The second question wants us to calculate our margin of error. So we're going to take 39% and we're going to subtract the low end, the 35%. And we get 4%. We're also going to take the high end, the 43%, and we're going to subtract that 39% or that mean, and we still get 4%. So what that means is our margin of error is equal to 4%. All right, let's talk standard deviation, and then we'll be done with margin of error and everything you need to know about statistics. So standard deviation is a measure of how spread the data is relative to the mean overall. So it's saying the lower the standard deviation, the closer to the mean the data is. And the closer or tighter your data is, the more accurate it is. The higher the standard deviation, the more widely spread out the data is, and it's less reliable. So we're always looking for a low standard deviation. If you're provided the standard deviation value, we can calculate the margin of error using a formula. So we're going to calculate the margin of error if you have a standard deviation of 4.3. So this is our standard deviation. I guess I don't need to label that. Let's just draw an arrow. Standard deviation. And we have a sample size, our N value is 160. So our margin of error is equal to 2 times our standard deviation divided by the square root of our sample size. When I put that in my calculator, I get a margin of error that is equal to plus or minus 0.68%. So I could be on the low end or I could be on the high end. And just so we know, the answer is already a percent because our standard deviation is included. So this percent is final. A school selected 400 of its 1,700 students to take a survey about their SAT scores. The standard deviation was 15, and the average SAT score for the group was 1,070. That was the average. So let's go ahead and take care of this. Our school selected 400 of its 1,700 students. So our sample size is 400 out of our population of 1,700. So we've got our margin of error is equal to 2 times the standard deviation. So I'll just say, actually, I'll go ahead and use the numbers. Our standard deviation of 15 divided by the square root of our sample size. And in this case, our sample size is 400. So we're going to go ahead and put that in our calculator. And we get our margin of error is equal to plus or minus 1.5%. And then the very last question. If the school instead chose 650 students to participate, would the margin of error increase or decrease? So we're going to go ahead and calculate it, but hopefully you have an idea or at least a prediction about what's going to happen. So our margin of error equals 2 times 15. Nothing changed with the standard deviation. The only thing that changed was that square root of 650 or the sample size. When I put that in my calculator, I got a margin of error that's equal to plus or minus 1.18%. 1.18% is lower than 1.5%. So the margin of error will decrease. And the reason it's going to decrease, I've said it a few times now, is when you increase the sample size. So when you increase the sample size, the margin of error goes down or decreases. So the margin of error decreases. And that's it. That's all. You do have homework assignments related to both of the statistics notes. And you also are going to have a quizzes where you can practice that. So hopefully you learned a little bit about statistics and you'll be ready for that open note quiz. Thank you.